Hello math learners! In this video, we are going to learn about polygons. So let's begin. What is a polygon? It is a closed figure connected by line segments with each endpoint shared only by two segments. Again, it is a closed figure. Now, the word polygon comes from two words, poly, which means many, and gon, which means angle. If we are going to combine these two words, polygon means a figure with many angles. Now, let's have examples of polygons. We have here a table. On the first column, we can see some examples of polygons, and in the second column, we can see examples of not polygons. Now, let's discuss why these figures in the second column are not polygons. Okay, let's start with this one. This is not a polygon because it is not a closed figure. Now, look at these examples. All of these examples are closed figures. It's because polygons should be a closed figure. Now, this next figure here, this one, has the same reasons with the first one. It's because it is not a closed figure. That's why it is not a polygon. Okay, for this third figure, the reason why this is not a polygon, even if it is a closed figure, it's because it was not formed by line segments. These are curved lines. So that means this is not a polygon. Okay, now for the last one. Okay, this one is not a polygon even if it is a closed figure and even it was formed by line segments. It's because of this point here. Now, from the definition of polygon, the endpoints of the polygon should be connected by two line segments only. Now, look at here, point C. Point C was connected by four line segments. Line segment BC, line segment BC, AC, and EC. So, that's the reason why this figure is not a polygon. Now, let's look at this example. As you can see, all the endpoints were connected only by two line segments. For point D, we have BA and BC. For point C, we have CD and CB. And the rest will follow. Okay, so these are some examples of polygons and not polygons. Let's have more examples. Let's determine if it is a polygon or not. Okay, this figure is a polygon. It is a closed figure. It was formed by line segments and all the endpoints were connected only by two segments. This is also a polygon. Next, this is not a polygon. It's because these are not line segments. Same reason, this is not a polygon. And the last one, this is a polygon. Okay, now let's proceed to the kinds of polygons. We have convex and non-convex polygons. First, let's discuss convex polygons. When we say convex polygons, a polygon is convex if and only if the lines containing the sides of the polygon do not contain points in its interior. That means if we are going to extend all the sides of the polygon, we cannot see points in its interior. We cannot see line in its interior part. While non-convex, or also known as concave polygons, it is a polygon, or a polygon is non-convex if and only if at least one of its sides is contained in a line. which contains also points in the interior of the polygon. So it's the opposite of the convex. That means if we are going to extend the lines of the sides of the polygons, we can see points in its interior part. Let's have examples. Now, what we have here on the left side, or in the first column, are examples of convex polygons, and on the right are examples of non-convex polygons. Now, first, why is this a convex polygon? Okay, let's try to extend all the sides of this polygon. So this will become this one. Okay, now as you can see, even if the lines or even if the sides are extended, we cannot see any lines in the interior part. We cannot see any point from the sides in the interior part. While this one, if we are going to extend all the sides, okay, as you can see, we have points or lines in the interior part of the polygon. These points here make the polygon non-convex. Okay, let's have another example, this one. Okay, if we are going to extend all the sides of this polygon, there are no lines or points in the interior part. Now, how about this polygon? Okay. Now, as you can see, we have points and lines in the interior part of the polygon. So that means this polygon is non-convex. Let's have more examples. Classify if it is a convex or non-convex. Okay, it's very obvious this is non-convex. It's because if we are going to extend this side, okay, we can see lines in the interior part. How about this one? Okay, this is also non-convex because if we are going to extend this side, we can have lines in the interior part. This is convex because if you are going to extend all sides, we cannot have points in the interior part. This is non-convex because if you are going to extend this side, you can have lines in the interior parts. And this one is convex. Okay, now let's have the classification of polygons according to the number of its sides. So these are the kinds of polygons according to its sides. Okay, if a polygon has 3 sides, it is called a triangle. 4 sides, it is called a quadrilateral. 5 sides, pentagon. 6 sides, hexagon. 7 sides, heptagon. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. 11 sides, hendecagon. And 12 sides, dodecagon. So these are some names of the polygons according to its sides. Okay, now let's determine the kind of polygon according to the number of its sides. So first, let's count. 1, 2, 3, 4, 5, 6. It has 6 sides, so that means it is a hexagon. Next, this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sides. So this means this is a hendecagon. This one. 1, 2, 3, 4. Quadrilateral. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Decagon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dodecagon. So those are the classification according to size. Now, let's have the classification of convex polygons. First, we have equiangular polygon. An equiangular polygon is a polygon with equal angles. The purpose of these tick marks here means that this angle here is equal to this angle, and this angle. Or, in other words, all the angles are equal. Next is equilateral polygons. An equilateral polygon is a polygon with equal sides. Now look at the figure here. As you can see, there are tick marks. So that means all the sides are equal, or all the measurement of the sides are equal. So that means this is an equilateral polygon. Next are the regular polygons. When we say regular polygons, these are polygons that are both equilateral and equiangular, which means all sides are equal and all angles are equal. Now let's have examples. Okay, which is not a classification of this given polygon? Okay, let's take a look at this figure. As you can see, we have tick marks on the sides, which means this polygon is equilateral. We can also see tick marks on the angles, which means this is equiangular. If they are both equilateral and equiangular, that means it is a regular polygon. So, this polygon is a regular polygon. How about convex? Is it a convex polygon? Okay, let's try to extend all the sides. If we are going to extend all the sides of this polygon, we cannot see any lines inside, or we cannot see any points in the interior part. So this is a convex polygon. Is it a pentagon? Okay, let's count. 1, 2, 3, 4, 5. It is a pentagon. Is it a concave? Now, since it's a convex polygon, that means it is not a concave polygon. So, if we are going to answer which is not a classification of this given polygon, the answer is concave polygon. That's all for this video, my math learners. Always remember, the only way to learn mathematics is to do mathematics.